Hi everyone, and welcome back to another introductory video for the topic of this week, now in clustering sampling. For this week then you'll be reading chapter 8 and chapter 9 of the textbook. However, you can skip subchapters 9.5 and 9.6 that will be mainly about costs associated with sampling. So in the cluster sampling scheme, we'll assume that the population is divided into clusters. So for example, in this image we have the population divided into 6 clusters, and for the sample, instead of sampling individuals, I'm going to randomly sample clusters in this population. So in this case I'm going to select randomly 3 clusters from this population and include in the sample all the individuals within each cluster. Okay, so if you do a parallel with the stratified sample that we've seen before, in the stratified sample situation, I also have the population divided into groups, which I call the strata. But rather than sampling the groups, I would go through every group and select some people from that group to integrate the sample. Okay, so you can see that this is different from the cluster sampling, where the unit of sampling is the cluster, is the group, rather than the individuals. Okay. Now, the probability of an individual in a cluster sample scheme to be selected for the sample is the probability of the cluster to be selected for the sample. So it's going to be m, little m divided by capital M, where little m is the number of clusters in the sample. So in our example, 3 divided by the number of clusters in the population, in this case 6. So let me now go through an example that is presented in the textbook. I don't particularly like this example, but I'll explain you why. But in any case, the example is about 5 developments of housing for senior citizens, as represented in the image, and each one of the developments, of the housing developments, contains 20 houses, or actually 20 apartments as the example in the book, but I'm going to represent the apartments as these little houses in the image. Okay, so I have in the population the clusters, the 5 clusters that represent each one of the housing developments. And from this population, I'm going to choose a sample of 2 clusters. Okay, so I have 5 clusters in the population. Capital M is equal to 5, and the number of clusters in the sample, it's going to be 2. So the total number of houses in the sample is going to be 2 times 20, so 40 houses that are going to integrate the sample. In any case, the sampling unit here is the cluster, so we have 2 clusters. Just as a note, the reason that I think this might be a little bit confusing example is because actually the houses could be seen as a cluster of people that live in the house. But the example is not focused on people. The unit of analysis is the house. Okay, so the little house, each one of these little houses here represent the little man or little woman that I had represented in previous examples. And this is where I think things might be a little bit confusing when reading the examples. So again, the cluster is the set of these houses, and the individual here each one of these houses. So let's think about an example where we want to estimate the total sum of certain quantity in the population. Let's suppose the total number of individuals with age above 65 years in all the housing developments. Okay, so I have the sample, and I can compute the total number of individuals by inflating, using the weight of representation, inflating the total number of individuals in my sample. So if you recall, in the notation, this x represents the sum of the variable in the sample. So I'm basically here summing all the values for the variable in the sample and again, each one of these x is associated with one house. So I'm summing over 40 houses, okay? And the xy is going to be the number of individuals with age above 65 in each one of the houses, okay? So if I sum all these, I get the total number of individuals in the sample with age above 65. And now to get an estimate for the total, I can inflate this. I can use the weight of representation by multiplying this by 5/2, okay? And this is the estimator for the total based on the cluster. So more generically, the total estimator is given by number of clusters in the population divided number of clusters in the sample times the total sum in the sample. Let's look now to estimators of means in the population. So suppose that we are interested in estimating the average number of individuals with age above 65 in each one of the housing developments. So basically I want the average, a mean for each one of the clusters, okay? So we can sum all the individuals with age above 65 in the total sample in the 40 houses, and then I'll divide by the number of clusters. And this is going to give me an average number of individuals with age above 65 per cluster, okay? So the general expression is given by x, the sum across all the sample, divided by the number of cluster. So this will give me, again, an average per cluster. But I would argue that the common interest is not at the cluster level, but at the individual level. So what is the average number of persons in each house with age above 65? Okay, and that, as you can see, it's going to be a different mean, so it will require a different estimator. And I'm going to represent, or in fact the book represents this mean x bar bar, okay? And x bar bar, so the average number of individuals with age above 65 in each house, is given by the average of the cluster divided by the average size of the clusters in the population. Or if you want to see this estimator in a different way, you can think as the average number of individuals with age above 65 in each one of these houses is given by the sum across all the sample, as we've seen before. So this is going to sum all the individuals that have age above 65 in the entire sample, so summing the 40 houses, and now dividing by the number of clusters 2 times the average size of the cluster, which in this case all the clusters have size 20. So this is 2 times 20 is going to give me the total number of houses in the sample, okay? But the general form of the estimator that is given in the book is this one. Now, the last thing I want to talk about regarding estimators is if you look at the expression of the standard error, in this case for the x bar bar that is presented in the book, you can see that this the standard error depends on this sigma 1x, and this sigma given by this expression below is the variability between clusters, okay? So basically for the standard error, so for the sampling variability, the variability within clusters doesn't contribute to the standard error, and the reason for this is because the entire cluster is selected for the sample, okay? So there's really no variability for the sampling arising from the cluster, the within cluster, because the entire cluster is selected. So the standard error is only going to depend on the variability between clusters. Now let's see how we're going to implement these estimators in the software. The example is the same. we want to estimate the total number of individuals with age above 65 in the 5 developments, and also the mean number of individuals with age above 65 that need a nurse. Okay, so we have 2 clusters of size 20 each, so I have a total sample size of 40 individuals, 40 houses in this case. The file tab9_1A DTA that you can find in the dataset folder, it's going to be used for this example. And the variables of interest here is going to be development, which identifies the cluster of each house. So each line in the dataset represents 1 house. The WT1 is the weight that is given by 5 total number of clusters in the population divided by 2 total number of clusters in the sample, so 2.5. The NGE65 gives me the number of individuals with age above 65 in each one of the houses, and the variable NVSTNRS gives me the number of individuals that require a nurse in each one of the houses. Okay, so I'm going to start with SAS. So in SAS, as usual, we have to read the data. In this case, I'm going to import the data because it's in Stata format. Don't forget to change the path of the data set. And to estimate the total number of individuals with age above 65 in the population, I'm going to use the proc survey means with the option sum. And now I have to add alongside with weight this command cluster that is going to tell SAS that the variable development identifies the clusters that the house belongs to. Okay, this in the same way, to compute the average number of individuals that will require a nurse per house, I'm going to use now the option mean because I want an average, and again together with weight I have to use this command cluster to identify the clusters in the sample. Okay, so the results in SAS, we're going to have an estimated number of individuals with age above 65 of 167.5, and the average number of individuals requiring a nurse per house is 0.575. Okay, so the last thing about Stata, you have the code in the book, but I just wanted to point out what is the difference with clustering. Before, we would set the design SVY set using here the _n, and this would tell Stata that my sampling unit was each one of the individual in the sample. Okay, now I'm going to use the clustering variable, so I'm telling Stata that this is now my sampling unit. Okay, this is the big difference for this type of design in Stata, and you can see that the results are going to be exactly the same as you obtain with SAS. Be sure to complete the exercises suggested in the notes, and as always, let me know if you have any questions.